where she has a degree in engineering. She has a master's in semiconductor and solar applications. Today, she's volunteering as a speaker with En-ROADS, which is a climate simulation exercise. In her spare time, she's a Trekkie, she likes Star Trek, and she's planning a wedding. So don't know how she found the time to speak with us today, but she did, and I look forward to hearing what she has to say.
Thanks for that introduction, Jeff. I'm going to go ahead and share my screen. So can you all see my screen?
Yes.
Great. Okay. So this is the En-ROADS simulator. It's free for everyone. I just shared in the chat this link. So anybody in their spare time who wants to mess with the simulator can do that. All the assumptions for this climate change simulator are transparent and listed on their website. You can also change the assumptions. So, you know, what is En-ROADS? It's a climate model that looks at if we change our supply of energy, transport, change our land and industry emissions, how does that change our outlook for our global temperature in terms of, you know, temperature? And you can also look at different other impacts. So you can look at CO2 concentration, greenhouse gas concentration, sea level rise, and you can see how that changes with different policy decisions. So one thing that I want to point out is that this is a globally aggregated model. So any change you make, let's say we subsidize renewables, that means that you're going to see this change real time on the graphs. But it also means that any change that we're making, we're assuming is implemented globally. Now, En-ROADS has a sister simulation called C-ROADS, and that looks at different country contributions to greenhouse gas emissions. This is looking at different sources aggregated globally. So what we're going to do today is we're going to try to, as a group, solve climate change and see, you know, basically what kind of policies, what kind of energy supplies we need, electrifying our transport, you know, if people biked more, you know, what kind of solutions do you have? Do you want to simulate? Do you want to look at like the price of energy? And we'll see if we can get to the Paris Agreement of 1.5, of 2 degrees, or, you know, aiming for 1.5 by 2100. Why is this important? Well, you know, climate change not only is going to have impacts on our food systems, it'll have impacts on, you know, what areas of the world are going to be livable. And so basically, we want to mitigate, you know, as much as possible the devastating impacts of climate change. And by making policy decisions today, we can reduce those impacts. So I want to kind of get started right away. This is meant to be more of a workshop than a lecture, and hear some ideas from you guys, what you think we need to do. And I can move these sliders in accordance. And if you want to actually look at more detail, you can see like how much we're technically subsidizing or taxing a certain energy source. And we can also change assumptions like climate sensitivity. And yeah, so I want to go ahead and get started. Does anybody have something that they want to test on the simulator?
Lisa,
Electric cars? I think I heard. Okay. So what if everybody just goes and buys a Tesla or a different electric car? What if we electrify all of our transport? So we can move this electrification slider here. So this is, and we can see how this is affecting our share of energy. So one thing to note, we can see this is coal, oil, and gas. So as we move the electrification slider to the right, you can see the red band here thinning. So that's going to be our oil usage. And what happens is you can also see as we move to the right, not only does the red band thin, but we also have our coal usage increasing and our natural gas usage increasing. So oil is going to largely be used for transport, so that's why it's going to decrease, but both coal and gas are used for electrification. So if we electrify our transport without thinking about where this electricity is coming from, we might not see that much impact on our overall temperature change. So that was a good one.
How about planting trees?
All right, so let's say that we plant a bunch of trees, and we can actually look at, well, how much area are we going to use when we plant trees? So we can look at this net land use and forestry emissions. So this is how much we're removing of CO2, how many gigatons of CO2 we're removing per year, so actually emitting. So removing, we want to get below the zero line. So for our land use, it's actually a net source of CO2 right now. If we increase forestation, we can see that line moving down closer to net zero. And then we can see it past net zero and starting to remove carbon below this line. Another good graph we can look at is our total emissions by area. So if we look at sources of net CO2 removal, we can see that afforestation by 2100, we are removing about 5 gigatons of CO2 per year. And we can look at just greenhouse gas emissions total. And so you can see kind of how much that is in comparison to how much we're emitting from other sources. So right now in 2022, we're emitting around, looks like 55 total gigatons per year currently. So that you can see this tiny little downtick, that's from COVID. So they take historical data, and then they also have multiple different models that they test this against. This is inroads is made by MIT Sloan. But again, those assumptions are changeable in the model. So you can see overall, it is a very small fraction of what we're emitting. So one of the things that we need to think about, not only removing CO2 from the atmosphere, but reducing how much we're emitting in the first place. So this biggest slice is coming from our energy usage, this black slice here. So we need to think about kind of how we're generating that energy in the first place. And you can see this substantial blue slice. CO2 is not the only greenhouse gas. We also emit methane, which is a very potent greenhouse gas. And we also have some industrial type emissions and F gases and nitrous oxides. And both of those also contribute to warming.
Replacement of coal and gas electric generation with nuclear.
Okay, so we can talk about subsidizing nuclear energy. And we can also talk about removing coal. So there's a couple of different ways that we can remove coal. We can tax coal, or we can also, one of the things we can do is say, we're going to stop building new coal power plants. So you can see that that actually has quite a significant effect. So coal is considered kind of the dirtiest type of energy. So per kilojoule of energy, that like the CO2 emitted is the highest per kilojoule of energy that you get from coal compared to oil, natural gas, or any other type of energy. So if we stop building new coal plants, that's quite significant. And I think you also mentioned subsidizing nuclear energy. So we can see this blue slice increase here. And one of the things you might look at is, well, if we're subsidizing, why isn't this increasing faster? So one of the things with nuclear, it's very expensive to build new nuclear plants. And there are different types of nuclear plants. So there might be smaller scale nuclear plants, and there's a like new zero energy. You could think of fusion, thorium power, for instance. But with any kind of new type of energy, you also have to think about the R&D development cycle, how long it's going to take to find the land, build the thing, get everything approved, and then as you do it more and more, that's going to get cheaper. But all of that R&D takes time. So you can look at basically how long it's taking to scale that nuclear up. And you can also look at, and you can say, well, I don't think that the commercialization time should be as long. So you can actually change that in your assumptions as well. So let's say that it actually doesn't take quite as long. That doesn't end up changing our simulation here too much. But these are definitely things you can think about and play around with on the assumptions.
Is the coal reduction mostly China and India?
So new plants are being built in China and India. There's also other players in coal. So Australia, for example, is one of the largest exporters of coal. And there's other plants built in Europe. Germany, when they decommissioned lots of nuclear power plants, they ended up relying more heavily on coal. So while China and India are large players, they're not the only ones affecting this. And for, I think C-ROADS would be kind of a better simulation to look at the different country contributions. But unfortunately, we don't have that breakdown here.
So what about increasing solar and wind as a source of electricity?
Yeah, so we can talk about subsidizing renewable energy. And before I move this slider, I want to hear some predictions about what you think this might reduce the overall temperature to by 2100 by subsidizing renewables.
2-2.
Okay. 2-2. Let's see. So we can see our slice of renewables is getting larger. So not that much. We went from, let's see.
You were at 2.9 and we went to 2.8.
Yep. So 0.1 degree. So one of the things that we can look at is of the existing energy profile that we have here, what are our contributors still? So we still have lots of natural gas and oil, and renewables, subsidizing them is not completely replacing those. One of the reasons is that oil is used as transport, and so we've reduced that quite a lot with our electrification. It has other uses as well. For natural gas, that's often used as a baseline energy. So we've heard from people that, you know, solar and wind, right, those are intermittent sources. The wind isn't always blowing, the sun isn't always shining. So one of the things that we have to do in order to have a reliable grid is to have a baseload reliable source of energy. Now, nuclear is one of the ways that we can provide that. But one of the cheapest ways and one of the ways that we currently provide that baseload source of energy is through natural gas, which is this blue line here. So when we think about providing renewables to the grid, we also have to think about how we're going to provide reliable baseline energy so that, you know, you don't have blackouts or rolling brownouts. One of the things that people talk about is battery storage, so grid battery storage. So that is currently being developed, and you can talk about also grid decentralization. And so those are both very large infrastructure issues with the way that our current grid is set up. But you know, you can think about basically how oil and natural gas will still be contributing even if we highly subsidize renewables. And you can also change kind of what these assumptions are as well, if you think that maybe that's an underestimate. But yeah, I'd like to hear some other ideas as well.
Building efficiency.
What was that?
Building efficiency.
Okay, yeah, so we can talk about how much energy goes into buildings. So, you know, it takes a lot of energy to heat and cool buildings. And if you have better insulation, for example, then it takes less energy to do that. Also, if you use like heat pumps, we've heard a lot about heat pumps recently, then it might be more energy efficient than your typical AC system. So if we increase building energy efficiency, we can see that actually our need for our overall energy usage is going down, and we can also see our energy CO2 going down. So if we increase that, we go from 2.8 to 2.6. So that was quite a significant change. And I think part of that too is since we're reducing our overall usage of energy, we're not using quite as much oil and natural gas.
Reduce methane. Reduce methane. Put diapers on cows. Reduce the population.
Yeah, reduce methane. Okay, yeah, so we can reduce our methane emissions. So when we think about, well, where is the methane coming from? We have a couple different sources. So you can see the blue line changing here. It's getting thinner as we're reducing it. One of the sources of methane is land use and agriculture. So methane is released from sources like cows, agriculture, natural gas, drilling, and waste. One of the nice things about En-ROADS is that you don't really have to know everything about how these different energy sources work or how the model works. You can kind of dive deeper into each of these sliders and say, well, if I'm reducing this, how much am I actually reducing it by? What are the assumptions that I'm making? And one of the other things that we can think about too is what are some of the co-benefits of making these changes? For example, we said we're going to stop building new coal infrastructure. Well, one of the co-benefits of building new coal infrastructure might be that we have less air pollution, and which means we have less health problems associated with air pollution. And we can even look at those in the impacts. So we can look at our air pollution from energy. When we turn on and off coal, we can see the effect on how much air pollution we have. So if we build coal infrastructure again and stop building it, we have quite a bit less air pollution. And yeah, methane's a really good one. So let's go back to our greenhouse gas concentration by area. So that one is here in the blue line. So we've reduced that significantly. We noted that we've reduced our energy CO2 quite a lot. So we need to pay attention to our other greenhouse gas sources, not just CO2 as well. So that was a really good one.
This population seems to be flat.
Yeah, so we can look at our global population graph here. So this is the model's assumptions as far as population growth. It flattens out right now at about 11 billion people. And that's actually something that I want to point out. So if we go to these Kaya graphs, we can see actually how it gets to this overall temperature. If we take our population and multiply it by our GDP, that energy intensity of the GDP, so how much energy does it take to get $1 out of the economy, and then how much CO2 do we emit per that energy consumption? So by increasing building efficiency, for example, it takes less energy for the same amount of GDP. By changing our energy sources, it takes less CO2 for that same amount of energy. And then how much CO2 we're emitting per year is going to be the multiplication of all of these. And then how much that CO2 and other greenhouse gases affects the temperature is based on our assumptions about climate system sensitivities.
Wow.
What's the secret?
Oh, yes. Drink more coffee.
I have a question about electrification of buildings and industry.
Yeah.
So we increase in solar power, decrease in natural gas heating.
Yeah, so if we increase our, let's go back to our main graph here. So if we increase our electrification in buildings and industry, we can watch our blue, which is this natural gas. And you can see that it does get thinner. And it does have a significant effect because we are reducing that natural gas use. So one of the things too that I encourage you to do when you're playing with this simulation is everything that we're doing, we're saying that we're implementing all of these policies in aggregate. We're doing everything and this and this and this. If you want to see what an individual policy does by itself, it might actually be completely different. So I can reset my policies and assumptions using this button, go back to the baseline scenario. And if I want to see what electrifying buildings and industry does by itself, I can move that slider by itself on this reset scenario. And then we might see that it went from 3.6 to 3.3. And it might not be as much as you would expect because we're still getting our energy sources from coal, oil, and natural gas. But also if we increase our energy efficiency in buildings, then maybe it doesn't take as much natural gas to heat it in the first place. So all of these effects do have kind of play off of each other. So you can see if we decrease our energy efficiency, then maybe electrifying might have more overall effect. So we would go from 2.5 to 2.2 versus energy efficient buildings. We went from 2.3 to 2.1. So you can kind of play around with how different things interact with each other as well. Because one of the things about coal, oil, and natural gas, if, for example, we just taxed coal but not natural gas, what you might see is that the natural gas and oil usage would go up a lot. And in fact, we kind of saw that when we closed down our coal plants, that both the oil and natural gas went up. And so this effect is called squeezing the balloon. If you reduce one of the fossil fuels, you might see an increase in the other two. So one of the ways to get around that is to, for example, enact a carbon price which will affect all of your fossil fuel sources and incentivize renewables and less carbon intensive energy sources.
Lisa,
Yeah.
one of the concerns about electrifying cars is the environmental cost to actually get the metals for the batteries.
Mm-hmm.
How do we take into consideration that environmental cost that when we look at, you know, all of us getting an electric car?
Right. So what you're talking about is something called a life cycle analysis. And this is something that people have done where you look at taking, you know, all of your raw materials from the source, everything that goes into the manufacturing process for the car, the use of the car, and then any recycling of the parts, any part energy and new raw materials that goes into the recycling of the parts, and then finally any retirement of the parts, how you get rid of them, and what effects those have. So life cycle analysis looks at everything from cradle to grave in the building of a certain basically anything. And for cars, people have done life cycle assessments on lithium ion batteries, on electric cars. So, you know, my answer is that you'd probably want to look at life cycle assessments of those things, but this model does not look at that. It is only looking at greenhouse gas emissions and kind of these secondary effects like on energy prices, and you know, there's other effects as well, but that's not looking at, for example, the area the land area that goes into mining. But I would definitely encourage looking that up. My personal opinion is that I think electrifying cars is very much worth it. But I do think that it is worth saying, I don't believe you, and checking that out through life cycle analysis yourself.
All right, thank you.
Yeah.
Okay, one or two more comments for Lisa.
Can you put up a solution that gets it below 2?
Yeah, so you know, we kind of saw that it takes so much effort to get us down to where we need to be, and we're looking at, you know, really extreme subsidies and afforestation. What if we forest as much land as possible? And maybe, you know, it's not realistic to go all the way to this top of this bar where we're reforesting a land the size of India. So, you know, one of the things that we can look at that is actually very effective is a carbon price. So we can see this dramatically reduces our use of coal, oil, and natural gas. One of the things that we need to worry about with a carbon price is the cost of energy. So if we have a carbon price, the cost of energy is going to spike, right? And that's going to affect everyday people. And so in order to enact a carbon price, right, you need to have political support to do that in the first place. And you're not going to have political support if everybody's bills are going up. So if we look at the revenue that you get from the carbon tax, one of the things that you can think about is, well, how do we use this revenue? So one of the things that you can do is use this revenue and give it back as a dividend to people. to offset that price that they're paying for the carbon tax. And so that's one very popular solution. It's been popular for 30 years, and we have not been able to pass it through our political system. So that's kind of where those barriers are. We do have lots of forms of carbon pricing globally. The EU currently is looking at a border carbon adjustment. So this is happening globally. The US is actually a little bit behind in that sense. But it is one of the most effective solutions. And we can also look at, okay, well, once we put so much carbon into the system, which is kind of where we're at now, how do we take it out? So we need to first and foremost decarbonize the economy, reduce how much carbon that we're putting in. So if we look at the greenhouse gas emissions by area, another thing that we can do is look at the technological carbon removal. So this is things like direct air capture, using mineralization in the soil to increase carbon capture. And so, you know, I'm a member of Citizens Climate Lobby, where we advocate for carbon tax, and I'm currently looking into getting into the carbon removal sphere as my day job. But you know, it's really going to end up being a whole suite of these solutions, because technological carbon removal actually is very, very expensive. And carbon price is very, very politically unpopular. So basically, it's going to take a lot of different things from a lot of different sectors. And we have to think about how there's no magic solution. We have to think about how much it's going to affect our lives positively. What could be some negative externalities? For example, with the carbon price, if we didn't have a subsidy back to the people would be paying a lot more in their energy prices. And how do we kind of offset those externalities that we don't want? And as we figure out ways to mitigate climate change, there's the other side of it, which is, you know, we've already put so much carbon into the atmosphere. We're already going to see changes no matter what. So the other side of it is, how do we adapt to those changes? And the answer is that we're going to have to do both mitigation and adaptation at this point.
Lisa, I want to thank you for your presentation. And it's obviously complex, and it's going to take complex solutions. And thanks for your work in it, and for your being with us today. Thank you very much.
Thank you.